What is up, everybody? Isaac here with Civil Engineering Academy. Appreciate you jumping on and checking out this podcast today. I have a question, though, for you. Do you know what a forensic engineer does? If you don't, then today's episode is going to be for you. I talk all things with Peter Marxhausen about forensic engineering, and he's a director of forensic engineering with Dux, a company that specializes in this field. And I just had a ton of questions about what they do, how they do it, what's the career path to get into forensic engineering, because I think it's a fascinating field to be in, and I'm sure a bunch of you out there think it's fascinating too. You just may not know much about it. So I bring Peter on. He's got some fascinating cases. He talks about how to follow into this, how to get into this career, and really what he does on the daily. So it's a fascinating episode. I really enjoyed my conversation with Peter. I think you will too. And it was part of becoming a forensic engineer. You do need to get your FE. You got to get your PE. Many times you got to get your SE to become a structural engineer. So if you need help with those things, definitely check us out at civilengineeringacademy.com. But I'm going to go ahead and shut up. Let me get to my interview with Peter. I think you're really going to enjoy this one. Peter Marxhausen with Dux, and we're going to talk about all things forensic engineering. We'll see you on the other side. See you in a minute. All right. We are rocking and rolling. Peter, thanks for joining me today on the Civil Engineering Academy podcast. I appreciate you doing this with me.
Hey, thank you very much for having me. I appreciate it.
Yeah, I'm excited to do this. I think I'm fascinated with what you do. So we wanted to pick your brain and get a lot of information about what you do. And maybe there's a pathway for other engineers to find their way into what you do. And I'm not going to spill the beans on that. So thanks for doing this with me.
Thank you. I'd like to share.
Well, I guess to kick this off, I always love to just kind of ask how you found yourself into what you do in the world of engineering. Did you have family members that brought you into that? Was it a dad or something? And kind of what was your journey into engineering itself?
I would like to tell you that I took the most direct approach to get here, and that would not be true. It was a circuitous journey. In fact, I first found myself in a school in California, a liberal arts school, thinking I wanted to be an engineer, not even knowing that I couldn't be an engineer. I guess that's a different conversation about parents preparing your kids for college adequately. So it was actually my sophomore year of college, thinking I kind of wanted to do something science related. I was taking aptitude tests. And those aptitude tests, and I took a series of 3 of them from different providers, and it said fingerprinting, a fingerprint investigator, policeman, it said teacher, and it said civil engineer. And I was looking at all those, and I was sort of biased in some of them. Like, I didn't really want to be a teacher, and I thought fingerprinting sounded boring. So I said civil engineering, and I started researching more what civil engineers do. And I thought that was really interesting. And the greatest bit of irony, which I've really only linked together in probably the last 10 years of my life, is that ultimately my job as a forensic structural engineer by day, and I teach at the University of Colorado as a professor at night, I ultimately link all 4 of those aptitudes. I do investigation of various matters. In terms of policemen, I think I participate, or I like to believe I participate in the judicial system, trying to help right wrongs. I am still a teacher. I'm technically hired as a professor 49% time at the university, and I do designs. I put out plans. I put out about 3 to 4 plan sets per week. And so from all 4 things, which I thought at one point were completely disconnected and unrelated, I have somehow brought together into my fold, and that is what I do, but during my waking hours.
That's awesome. So I don't know if anybody wakes up and says, I'm going to be a forensic engineer. Like, you had to build up the skill set to become a forensic engineer. Is that correct? And like, what did you do to get to that point?
That is correct. And so let's at least embrace that for a traditional civil engineer, and even engineers in general, you view yourself as breaking new ground and creating these monuments. At least when I thought I was in school, I was going to design skyscrapers and the things that are going to be on the covers of magazines, hospitals, and schools. That was my vision. When I got out of school initially, I was working for a multidisciplinary company structural, mechanical architects, and they kept me busy. And as you might know, in the engineering field, there's always like these troublesome cases or existing buildings that are having problems and you got to figure it out. Uh, Most, I would say, engineers try to steer away from that, but some gravitate toward that. And so, what we have in the construction industry is sort of like this collect all. When things go wrong in infrastructure, there's the involvement of insurance companies, and there's attorneys, and there's litigation, and there's questions that need to be answered. And I think for a conventional structural engineer, mechanical engineer, civil engineer, when they pry open that closet and look into that dark underbelly of the industry, a lot of them say, "I want no part of this. This seems very fraught with trouble. I don't want to deal with attorneys," and they go the other way. I, for whatever reason, didn't know enough to say no, and I just kept walking more toward it. I see problems and I like solving them. I like educating my clients. Usually it's attorneys saying, "Explain to us what really happened and walk us through. Did our client do something wrong? Did our client not do something wrong?" And I have found myself more and more embedded in that industry over the last quarter century, now that I've been doing for about 25 years. And for all of us that I would say are collectively in this industry, we almost always have that a similar story, that we were asked to do something, and because we didn't reject it or turn away from it, we got drawn further into this industry where it's just now what we consider to be just our area of practice.
Wow, that's awesome. And so, did you transition from doing structural engineering work to specializing in forensic engineering? I mean, you did that at some point in your career. So,
So
what was that transition?
I would like to say there was just a switch that flipped, but it was a slow progression. During the first 5 years of my tenure at a design firm, I became more and more increasingly involved in forensics. And to give a picture in terms of what that looks like, I've tracked my workload over about the last decade, and 40% of my work assignments are simply designing repairs to damaged structures, whether it be because of a fire, a vehicle crash, an explosion, a tornado. And we consider that still forensics because it's not a traditional relationship with a client. If you've got an owner that says, "I want this brand new warehouse building," the owner kind of gets what they want. When you're doing damaged structures, especially in the context of insurance, you have a lot of questions to answer for various people. For example, if a driver of a truck, which this would be an example of one I did yesterday, driver of a truck drives into a building, you've got the insurance company for the driver of the truck, you got the insurance company for the property owner, you've got the property owner, you've got the contractor. Generally, you have a building department. This other one I'm looking at, we also have a historical society. You've got all these different interests involved in this one case, and trying to balance all of them, yet still arriving at the same, at least at the correct answer with a safe building. A repaired building is more complex than traditional design. So that's about 40% is just designing repairs in complex scenarios. Another 40% is what I would call direct litigation support. I think that may fall under the conventional thought process of where I'm working for an attorney or I'm retained by a law firm to offer opinions in terms of what might have happened, whether it be a construction accident, or a construction defect, a fatality, an injury. Speaking from an engineering perspective, what happened, conducting an investigation, writing a report, being deposed on that report, and possibly testifying at trial or arbitration or mediation regarding those findings. That'd be another 40%. So you have 40% is just designing repairs, 40% is we call litigation support, and then 20% is what we call first-party claims. So let's say an insurance company who insures a property, they receive a claim, say, "We've got cracks in our building." An insurance company or an insurance adjuster doesn't really know what's caused that, and it might be very important. Maybe that crack might be something the insurance would pay to fix if it was caused by snow, but not soil movement, or maybe it'll be covered if it was caused by wind, but not flooding. And so various entities will hire me and my company to say, just go out, find out what they're claiming, and tell us what caused it and how to fix it. And so it's a first party claim assessment. That's about 20% of my work, and that always involves a lot of variety, because you never know what you're going to get. Everyone has problems with buildings, and so stepping in the middle of somebody else's life in the midst of that building and trying to figure out what is ultimately happened and what is its history and how do we get here and how do we move forward. Every day is something just a little bit different.
I'm curious, do you notice you get involved with, I guess, forensics more when a project is new, like the building is just finished and we're noticing problems? Or is it further down a timeline of a life cycle of a structure or building? Like, when are you seeing involvement in infrastructure projects and doing forensics on them?
It's funny you say that, because it's almost like an inverse bell curve. There's a lot of upfront problems, troubleshooting, and litigation when a structure is first built. And then you've got years, 4, 5, 6, 7, 8, 9, 10 through 15, maybe, where things go kind of quiet. But then as we start to approach degradation, exposure to larger storms, just statistical anomalies of the occurrence of fires or vehicle impacts or deferred maintenance, then all of a sudden there's an uptick. So I've got usually a whole healthy amount of older buildings, established buildings, and a whole bunch of new construction, and not a lot right in that middle age period where maybe it's, I don't know, 10 to 15 years old.
That's interesting. This just popped in my head, but there seems to be kind of a big conversation online sometimes where a PE or a structural engineer stamps the drawings for a building, and that lasts for the life of the building, as opposed to, say, a real estate agent that comes in, does a transaction, they're done, they move on. But could you maybe touch on, like, a lot of engineers are risk adverse, and they're worried when they stamp something that their signature is on there for the life of that structure. In the work that you've done, have you noticed that comes up? Is that an issue? Like, what can we do to put engineers' minds at rest that, even though they're stamping this as the structural engineer or the PE, that the profession that they're going into, you're designing something because you have the competence and the skill set to do so, but maybe as a forensic scientist, that you shouldn't be too worried, or should they be worried?
Well, Isaac, you've decided to go for a swim in the deep end of the pool here. I'm going to tell you should be worried.
Okay,
but
that's what I want to hear.
That worry should come naturally. If you are a civil engineer at your core, embedded in the cockles of your heart should be this desire to help the public. If you're just in civil engineering or even engineering just for the money, I would maybe offer that you're not in the right profession. If you are a civil engineer and you got into this because you said, I want to make planet Earth better, I want to make it better for society, I think you are in the right place. And I think a smart civil engineer realizes if they're designing a bridge or a building, a wastewater treatment plant, a road or a culvert, that is society that is going to be dependent upon the proper function of that infrastructure for the life of whatever that is. And sometimes that could be well in excess of 100 years. Mm-hmm. And I think also a smart civil engineer, knowing that they want to do no harm and they only want to help society, is given pause when they realize that if there is a problem embedded in that particular design, it could have the opposite effects. So I am not going to tell a practicing civil engineer, don't be worried, in the sense that you should be lackadaisical about it.
Yeah.
I think you should consider the greater impact of what you do. Herbert Hoover, in his memoirs post-presidency, has this really great quote about why civil engineering is such an incredible profession. And I'm not going to be able to recite it all, but he talks about, unlike unlike the attorneys who just get to make arguments, their daily bread, or unlike doctors who simply bury their patients, if a civil engineer's work product does not function, and to quote Herbert Hoover, he says, "You're damned." You cannot argue your shortcomings into thin air. It is always out there for the public to see. It gets rained on, it gets driven, it must hold up to strong winds. All of our work is for everyone to see, and we're all relying upon it.
That's a great answer. So, yeah, I mean, if you want to contribute to society and this is the field you want to be in, then your designs need to be sound. And so I think that's great advice. I was just thinking as well, in a lot of times in cases that I've seen in the world that I'm in, utilities, the first thing that comes up is, was the issue engineering or was the problem construction? And I'm just curious, in the cases that you've had to run through, do you see that piece coming up quite a bit? And how do you investigate matters where construction maybe was a problem, as a forensic engineer? How do you dive into those details?
Well, every failure is going to have a unique flavor to it. Pulling it all apart is part of what I do and others that do forensic engineering regularly do. It comes down to, well, what is the issue and how do we get to that issue? It's certainly, as quite frequently, a construction issue. I would say construction activities are the largest component of structural failures by the numbers. But also, sometimes there are shortcomings with designs. We are ultimately human. Humans can take 2 + 2 and get 22. So errors occur in plan sets. Sometimes there's misguided assumptions. And I am not going to tell your listeners that it's never engineering and it's never construction, because on any given day, it feels sometimes like a dartboard. Can be any one or sometimes a combination of both.
Yeah, that makes sense. Do you have any favorite cases that you've worked on? Could you, I mean, I'm not maybe asking for specifics, but like, has there been some fun cases that you've worked on personally?
Oh boy. The ones that stick in my brain that are the hardest to get out of my brain. And you asked me a fun question. But the ones that always stick in my brain are the ones that involve fatalities involving young children, which is not fun at all, but they stick inside your brain and sometimes you just can't get them out. The one that I think I tell the story the most, and I have a traveling presentation on forensic engineering from a case study standpoint. I have one where a plaintiff was suing because he had his crotch and genitalia run over by an F-250 Ford pickup. That's an interesting story. But I think my last one in my storybook of all my case studies that is the most interesting, because you can never see where it's going, involves a municipality building a roadway in the mountains. And through the construction of that roadway, an excavator dug out from under itself. And that excavator, it was a tracked excavator, rolled down the mountain and hit a historic home. And so this was a very complicated case at the onset, because we've had the city, we had the general contractor, we had the excavator, we had a rental company that actually rented that excavator. We had to rent the largest crane in Colorado to pick up the excavator off the hill and move it off. In the process of moving it off, it hit the home again. So there was secondary damages. We had the Historical Society, because the home was built in 1890, and the Historical Society said we want it exactly like it was. We also had the local building department said, we don't want anything like it was. We want it all new to the current code. So there's a lot of controversy. And where this ultimately ends up is litigation that goes on for 12 years. And the homeowner of that house that got hit by the excavator goes to jail.
What?
There you go, right? And that one is very, very difficult to see coming. And through a long series of steps, and this all came out in court, the homeowner ultimately saw his old, fairly decrepit home get fixed through my design. I actually designed all the repairs. We oversaw the repairs, and we fixed a whole lot of bad problems like leaky roofs, leaning wall, failed chimney. We made it all really relatively good. And this homeowner saw this as free money. And he testified, I'm not making any of this up. He testified that he thought free money was good. He had another decrepit building around the corner, ultimately committed arson, and they got involved in that one too because it was a damaged building. They were able to convict him, and he went to and he was sent to jail. And so all of it all linked together for a very long narrative of events.
Holy
That
cow.
yeah, you can never really see where it's going, which is also why, as a forensic engineer, you just really need to remain objective throughout the process and collect as much data as you can and report that to whoever needs to make decisions.
Okay. Wow. I didn't know where that was going, but those are pretty cool cases. So, exciting stuff. Well, I'm sure my listeners, a lot of them, may be very interested in this, but what are some steps or tips you would have for somebody that wants to pursue a career in this field?
So, for the field of forensic engineering, you need to not only care about the public, like all engineers should, but you also need to have a heart of a teacher. It is not the role of the forensic engineer to make a determination. The role of the forensic engineer is to educate your client or the trier of fact, whether it be a judge or a jury or an arbiter. And I want to make a distinction there. As a conventional design engineer, when they say, can you design the structure? Your word is what ultimately gets carried out. Your opinions get carried out. If you say this is the column size, then that's the column size. If this is the amount of rebar it needs, that's what it is. You have complete control over what gets built. In forensics, I do not have control over the outcome of that litigation. That resides in the hands of the jury and the judge or the arbitrator. So I'm only presenting information, I'm teaching, I'm educating, I'm allowing the trier of fact to see a case through my eyes as a person that has specific education, training, and knowledge in a field of civil engineering and structural engineering. So you need to have a heart of a teacher. You still need to care about the public. You need to be inquisitive, constantly asking questions. How, if this is true, then what else must be true? Or maybe this isn't true, and how could I prove a negative? How could I prove a positive? And document things. And probably the fourth aspect of being in forensics is understanding that the stresses are high and the timelines are always very, very short. Attorneys are always behind. Court mandates deadlines, right? The reports have to be submitted by this date, and the turnaround time has always got to be quick. And so it seems like it's always an emergency. Also, for my repairs, if I have a let's say a commercial building that caught fire, we have employees that are displaced, we've got a business that's down. Every person in that scenario is, we need the engineer out there today, and we need to get the plans done as soon as possible because we need to get up operational. I've had companies that lose up to $50,000 to $100,000 a day for every 24 hours that they're down. That's a lot of pressure on the engineer to get that design put out, but not lose control over the overall quality that must be inherent to the design.
That is very stressful. So, I mean, those are all great tips, and I don't know, I guess they're soft skills. But what about credentials? Like, you need your PE, you need your SE. Is there anything credential wise that you find yourself that you should be headed towards?
You are correct. PE licensure, passing your FE are all critical components to being a forensic engineer and even engineering. Those are the keys to unlock the door to pass through. And for those that are contemplating this career, even a career in just general engineering, doesn't have to be forensic engineering, is to not lose sight of that, not give up hope, keep working, pass the FE, pass that PE exam, stay at it, keep trying, because it is a very wonderful career to be in.
That's great. I guess maybe to wrap this up, or just maybe a few more questions I have, is like, how have you been able to deal with these pressures? You mentioned these extreme timelines, and engineers feel the pressure often. Do you have any tips on kind of neutralizing that? How do you deal with high pressure situations?
Well, to the audience, they can't see this, but over the door to my office, I have a large sign that says, "It is what it is." I am regularly presented with tight timelines, bad facts. I mean, sometimes you get clients that really did mess up and cause a lot of damages, and I got to report that back to the attorney or the insurance company saying, "Yeah, your client. I know you want me to tell you that there's nothing wrong or nothing needs to be fixed or your client didn't screw up, but it is what it is." And so sometimes I find a lot of peace in, I didn't create the problem. I didn't create the fire that burned down the structure. I wasn't the drunk driver that ran through this restaurant at 2 a.m. in the morning. I didn't create the problem. I'm just here to provide the information so other people can make decisions. I am here to provide my expertise, my engineering knowledge to help you move forward. And that is probably, when I recite that to my head, is the best way to lower my blood pressure, calm my heart down, and probably sleep a little better during the night. Because you're correct that sometimes those stresses, especially fatalities, big dollar cases, we're talking potentially, I think my largest case was upwards of $100 million. There's a lot of stress and a lot of pressure. And I think that is my best tactic that I can use if I hope to get any sleep at all.
It is what it is.
Yes, it is what it is.
I love it. Well, this has been fascinating. It's a field that I do think people have curiosity about, and I think they would pursue it more if they had more details about it. So I appreciate you jumping on, sharing those details. If people did have more questions about becoming a forensic engineer, would there be a place I could point them to reach out to you or the company or anything like that?
Sure. Probably the best place to reach me is through my LinkedIn profile. First name Peter, Peter, last name Marxhausen, Marxhausen. My daytime employer is Dux Forensics, Dux Forensics, which is Latin for leadership. And in my evenings, I teach at the University of Colorado, Denver in the Civil Engineering Department, where I teach Introduction to Civil Engineering, Senior Design, Timber Design, Advanced Timber Design, and Masonry Design as well.
Man, he's giving back. He's doing it all. Peter's awesome. So, Peter, thank you for doing that. We'll leave the show notes, in our show notes, those links, and make sure people can reach out. I think what you do is fascinating. So thanks for letting me ask you some questions and get more info. Oh, you got one more.
Isaac, I want to thank you for everything that you're doing. I do a lot on my end, wherever I can, to elevate this profession. I love being an engineer. I love being a civil engineer. I like the fact that when I wake up in the morning, I know that I am going to make the world a slightly better place by the time I go to bed. And I appreciate everything that you do at your end for multiple years, trying to elevate the engineering and the civil engineering profession. So thank you.
Appreciate that. Thanks for the kind words. Yeah, you kind of get lost in the weeds a little bit when you're doing podcasting all the time, but I appreciate those words. We do love giving back, and we want to inspire new people to find this profession. I think it's a very worthy profession to be in. It's exciting. As society grows, we need more engineers, and it is around us every single day and affects our lives in all ways. So anyway, thank you, Peter. Thanks for saying that. And thanks for being part of the show.
Thank you.
See ya.
See ya.